Hey guys, it's Carrie, and this is the answer key to homework number 2. So the sequence below shows a pattern. Is the sequence above arithmetic or geometric? So in order to figure out if it's arithmetic or geometric, we have to find the pattern first. So from 2 to 7, 9 to 16, 16 to 23, it looks like the pattern is plus 7. So because we're adding the same amount each time, this is an arithmetic sequence. Determine the common ratio or common difference. It's always a common difference if it's arithmetic, so the common difference is plus 7 or just 7. Determine an explicit formula for the nth term of the sequence. So for the explicit formula, that's the formula where you want to be able to jump directly from the beginning to anywhere in the formula. So I'm looking for a way to connect from the second one all the way up to whichever one I want to go to. So let me start with the ones that are showing, A1, A2, A3, and A4. So in order to get to A4, if I wanted to jump straight from here to here, I could say start at the beginning, 2, and it looks like I have to add 7 1, 2, 3 times. So that would be a formula for A4. Let's just check it. 2 is 2, 7 times 3 is 21. This does give me the 23 I wanted. To get A5, the only thing that's going to change is I could say start at 2, and instead of adding 7 3 times, to get to A5, I would add 7 one more time. So that would be 2 plus 7 4 times. So that would be, whatever, 30 exactly. All right, so applying this reasoning for specific cases makes the pattern very apparent. So to get to A sub n, I would need to, well, where n is any number, I would need to take 2, and when I wanted to go to 5, I added 7 4 times. When I wanted to go to 4, I added 7 3 times. To get to n, I'm going to take 2 and I'm going to add 7 1 fewer times. So this looks like a formula that will work for any value n. So using this formula in part D, if I want to find A sub 10, it would be 2 plus 7 times 10 minus 1. So A sub 10 is equal to 2 plus 7 times 9, which is 65. Next problem. All right, the sequence below shows the pattern. Is it arithmetic or geometric? So it is geometric this time because the pattern is times 4. So determine the common ratio or common difference. Because it's geometric, we're going to have a common ratio of 4. Determine an explicit formula for the nth term in the sequence. So this time, if we think about it very similarly, let me start with A4. To get to A4, I'm going to start with the first one, 2, and I multiply by 4 3 times. As we talked about in class, repeated multiplication, 4 times 4 times 4, can actually be better written as 2 times 4 cubed. So we have a really similar pattern to we had with the arithmetic series, but instead of adding 7 over and over, we're multiplying by 4 over and over. So we get a formula that looks somewhat similar to the arithmetic series, but it results in an exponent instead. So for A sub n, the formula will be 2 times 4 to the, well, to get to the fourth one, we multiply by 4 3 times. To get to the nth one, we'll multiply by 4 n minus 1 times. I'm going to leave determining A sub 10 to you guys, so you figure it out. For problem number 3, the sequence below shows a pattern. I'm actually going to let you guys figure this one out too. I think you'll have no problem working with negatives. So if that challenges you, great. For problem number 4, this problem looks crazy, so we definitely should go over this one. The sequence below shows a pattern. So it can be very hard to figure out what pattern this is because I put in all of these x and y's for no reason. So let's see. Starting with just the number, though, I think I can start to get some insight. So let me reduce the pen size. Here we go. So 3 times 4, and I'm not going to use the x for multiplication just because I'll just use a dot, times 4. And then we want to go from x to the 5th to x to the 7th. We want to go from x to the 7th to x to the 9th. So even though it looks like we're adding 2 x's, in order to add 2 to the exponent, remember we only add the exponents if we're multiplying by the same base. So it looks like what we want to do is we want to take x to the 5th and do times x squared. Because x to the 5th times x squared, we would add the exponents, giving us 7. All right, for y, it's going to be the same thing. We want to multiply by y cubed, because y squared times y cubed is y to the 5th. Okay, so it looks like we found a pattern that works for the first one. Let's test to see if it works here. So 4x squared y cubed. 12 times 4 is 48. X to the 7th times x squared is x to the 9th. Y to the 5th times y cubed is y to the 8th because you add the exponents. So we found the pattern. It seems like it's multiplication by 4x squared y cubed. So because it's a multiplicative pattern, it's geometric. It has a common ratio, and this is the crazy part, a common ratio of 4x squared y cubed. All right, so it says determine an explicit formula for the nth term in the sequence. So for part B here, it's a sub n is equal to, and we're going to construct this the exact same way that we constructed the sequence for problem 2. Start at the beginning, and then multiply by the common ratio to a power of n minus 1. So start at the first term, 3x to the 5th, y squared. To get up to the second term, or sorry, that's the third term, a1, a2, a3. To get up to the third term, we multiplied by this piece twice. To get up to the nth term, we're going to multiply by this piece n minus 1 times. And that is actually our final formula. It's kind of hideous, but it's the exact same idea as before, just with a more complicated common ratio. Next up for problem C, determine a to the 5th. Oh, why did I ask this problem? Now I have to do it. A to the 5th is equal to 3x to the 5th y squared times 4x squared y cubed to the 5 minus 1th power. All right, so 5 minus 1, ooh, wow, I erased too much. 5 minus 1 is 4. So a to the 5th is equal to 3x to the 5th y squared. Raising this to the 4th power, I get 4 to the 4th power, which is 256. X squared to the 4th power, which is x to the 8th. Y to the 3rd to the 4th power. Powers of powers multiply. That gives us y to the 12th. And here comes the really challenging one. I have to do 3 times 256. That is 768. X to the 5th times x to the 8th is x to the 13th. Y squared times y to the 12th is y to the 14th. So I think a to the 5th is 768, x to the 13th, y to the 14th. Wow. If you got that problem without having the video, you should be really proud of yourselves. That was a really tough one. For problem number 5, there are 2 sequences shown below. Determine the first 5 terms of each sequence. So this problem is really important to me. It's probably the most important problem in the whole homework set. Because what it talks about is the difference between a sub n minus 1 and n minus 1. So a sub n refers to the previous amount, or the amount at the nth value, the amount of the nth value. So a sub n minus 1 is going to be the previous amount. So the way I like to do this problem is I like to think about whenever I see a sub n minus 1, it's a sub n equals 5 plus 2 times the previous. We're going to see how that's different in problem part B here on this side. But before we do that, let's finish this one up. So a1 is 5. a2 is 5 plus 2 times the previous. 5 plus 2 times 5, that's 15. a3 is equal to 5 plus 2 times the previous. The previous was 15, so we get 35. a4 is equal to 5 plus 2 times the previous, which was 35 in this case, so we get 75. And a5 was equal to 5 plus 2 times the previous, which is 155 in this case. So we have all of our values for a1 through a5. Let's see how things change in the second problem. So in the second problem, the major difference is n minus 1 is not the previous amount. What n minus 1 is if you're looking for the 10th one, n minus 1 is the 9th one. So it's the previous index, not the previous amount. All right, let's see how that comes into play when we're calculating this. So we have a1, a2, a3, a4, and oh wow, I should have given myself more room. Here we go, sorry. A1, A2, A3, A4, and A5. So for A1, A1 is 5. For A2, it's 5 plus 2 And then when we say n minus 1 here, it's not the value. It's not 5. It's n minus 1. Well, if n is 2, 2 minus 1 is just 1. So you get 5 plus 2 times 1, which is 7. For A3, we get 5 plus 2 times 3 minus 1. 3 minus 1 is 2. We get 9. A4 is equal to 5 plus 2 times 4 minus 1. 4 minus 1 is 3. A4 is equal to 11. Wow, my notation here is getting very different as I'm going through this, but 11. And then 5 would be A5 is equal to 5 plus 2 times, not the previous amount, not 11, but the index minus 1. The index minus 1, so 4. So A5 is equal to 13. Wow, I did the same thing with the notation. A5 is equal to 13. So we get all of our values here. So the difference between a sub n minus 1 and n minus 1 is this. A sub n minus 1 is the previous amount, and n minus 1 is 1 less than the current index. So this is probably the most